we're going to be solving equations of the form ax squared plus bx plus c equals 0. We've been there, done that, originally in Chapter 6. And in Chapter 6, the method we used always was factoring. But unfortunately, most real-world problems don't factor. I would say 99.9% of real-world problems don't factor, and every now and then you'll run into a formula that does. If you're going to take 150, one of the things you do in 150 is work with mathematical models, and most of those models are really kind of ugly. They don't factor, so you need other methods. So Chapter 6 method was factoring. In other words, we took the quadratic, set it equal to 0, factored it, set each factor equal to 0, then solved for x. And then here's another example, x squared minus 16 equals 0, factor, set each factor equal to 0, solve for x. The first new method that we're going to add in this chapter is called the square root property. And if I were to take a look at using the second example from above, x squared minus 16, and by the square root property only works for things that are of the form ax squared plus c equals 0, and you will notice that there is no x term. There's no x term. So it is a binomial that's got a squared thing and a constant. There's no x term. So if I were to look at this and say, yeah, I could factor it, but if I set x squared equal to 16, you would basically say that x is 4, because that's a good guess. So what do I square to get 16? It would be 4. However, that's not true. Not only is 4 squared 16, but if I take the opposite of 4, the opposite of 4 squared is also 16. So the answer to this problem really is x equal 4 and x equal minus 4. Just got two answers, 4 and negative 4. As you square a negative, it's positive. Square positive, it is also positive. Now what the square root property does is we're dealing with unsquaring. It's kind of like when we got rid of square roots, we squared. It's unsquaring. So it says if I've got a square root, I square both sides. Now, technically speaking, what the square root of x squared is the absolute value of x. Because if x can't be negative, otherwise you have imaginary answers. So absolute value of x. Well, if you have absolute value of x is equal to 4, then x could be either 4 or minus 4, since the absolute value of 4 is 4, and the opposite of the absolute value of 4 is also 4. Well, we don't deal with absolute values in that way. What we do is this. If we take x squared is equal to 16, we take the square root of both sides. We say the square root of x squared is x, but to compensate for absolute value, we include the positive and negative of that answer. We say plus or minus the square root of 16. Now, plus or minus is hard to get used to from the standpoint that even I have it up, even my calculuses have trouble remembering the plus or minus. And it says x is plus or minus 4. That's two answers. It says x is the positive of 4 and x is the negative of 4 when it says plus or minus 4. So in general, if I have anything squared equaling to some number, I take the square root of both sides. Don't forget the plus or minus. The square root of n squared is just n. This is plus or minus the square root of p, so it has two answers. N is the square root of p, or n is the opposite of the square root of p. So there should be square roots around those p's. It has two answers because of the plus or minus. That's the square root property.